Hello and welcome to the tutorial session. So today's session we will continue to discuss a few questions, few MCQs, basically some gate questions based on plane waves. It's a continuation of the previous session. So to discuss the very first question here, if a right-handed circularly polarized wave is incident normally on a plane perfect conductor, then the reflected wave will be. So the question is, answer options are right hand circularly polarized, left hand circularly polarized, elliptically polarized with a tilt angle of 45 degree, then horizontally polarized. Okay. So to answer this question, so we know that there is an interface at z equal to 0 and there is an incident wave which is normally incident, which is a RHCP, and the reflected wave is LHCP. Okay, and this is a perfect electric conductor. So if the wave is incident on the perfect conductor, the reflection coefficient gamma is equal to -1 and ER naught is equal to EI naught angle 180 degree. So we can say there is a phase change of 180 degree. If the incident wave is traveling along plus z direction, so say this is z equal to 0, so we can say the incident wave is along plus z and the reflected wave is along minus z. The reflected wave is, so incident wave is RHCP and the reflected will be LHCP. Okay, so the answer option in this question is, this will be left-handed circularly polarized because the incident wave is right-handed circularly polarized. Now moving to the next question. For an EM wave incident from one medium to second medium, the total reflection takes place when the angle of incidence is equal to Brewster angle with electric field perpendicular to the plane of incidence. Angle of incidence is equal to the Brewster angle with electric field parallel to the plane of incidence. Angle of incidence is equal to the critical angle with the wave moving from denser to rarer medium. Angle of incidence is equal to critical angle with wave moving from rarer to denser medium. Okay. So the question is, when do total reflection take place? So to answer this question, we need to understand what is Brewster angle and what is critical angle. So critical angle is the angle at which the total internal reflection takes place, as we know from the theory. For total internal reflection to take place, the wave should move from a denser to rarer medium and the angle of incidence should be greater than or equal to the critical angle. Okay. Now, what do you mean by Brewster angle? So, Brewster angle at this, so whenever angle of incidence is equal to Brewster angle, there is no reflected wave. Okay, that means there is no reflection in case, and that is in case of a parallelly polarized EM wave. Okay, so that is when the electric field is parallel to plane of incidence. So here the question is about for an EM wave instant a total internal reflection will take place, that is happening only at the critical angle, and we should know that the condition is wave moving from denser to rarer medium. So option is option C. So total internal reflection takes place when angle of incidence is equal to critical angle with wave moving from denser to rarer medium. In a good conductor, the phase relation between the tangential components of electric field Et and magnetic field Ht is as follows. Okay, so the question is on the relation between electric field and magnetic field in case of a good conductor. Okay, so if you remember, in the last session also, we looked at the relation between E and H. So eta is equal to E by H, which is nothing but square root of j omega mu by sigma plus j omega epsilon. In case of a good conductor, okay, what is special with a good conductor? Sigma will be much greater than omega epsilon. So this expression for eta will be square root of j omega mu by sigma, okay, which is nothing but root of omega mu by sigma and e raised to j 45, okay, or I can say angle 45. So which means that E leads H by 45 degree. So from the options given here, the right option is, so ET and HT are in phase, that is wrong. So E leads HT by 45 degrees. So that answer is option D. So this was a question from GATE in 1988. Now moving on to, let us discuss some relevant questions. Okay, there is another question on skin depth, which is a really good question. Skin depth of copper at a frequency of 3 gigahertz, okay, is 1 micrometers. At 12 gigahertz, a non-magnetic conductor, whose conductivity is 1 by 9 times that of copper, okay. So there are two conditions at 12 gigahertz and also conductor whose conductivity is 1 by 9 times that of sigma of the copper, sigma of copper. For that, what will be the skin depth? Delta 2. Okay, so to answer this question, we know the expression for skin depth. So that is inversely proportional to square root of f and sigma. Yes. Now let us look at the full expression also. Okay. So what we can do is, okay, let us write it this way. Delta 1 by delta 2 is equal to root of f2 sigma 2 divided by f1 sigma 1. Okay. So here square root of F2 by hello. Okay, so to discuss, okay, carry on, continuing with the discussion here. So delta 1 by delta 2 is equal to root of F2 sigma 2 by F1 sigma 1. Here the frequencies are 3 and 12 gigahertz. So let us write it down. F2 as 12 and F1 as 3. And sigma 2, that is 1 by 9 times of sigma 1. That is the sigma of copper. So let us multiply this like 1 by 9. Sigma 2 is 1 by 9 times of sigma 1. So sigma, sorry, sigma 2 is 1 by 9 times of sigma 1. Sorry, sigma 2 1 by 9 times of sigma 1. Okay. So delta 1 and delta 2, here in the ratio we can write it as 1 micron divided by delta 2. Okay. So based on that, delta 2 is so 1 micron by delta 2 is equal to square root of 4 by 9 will be 2 by 3, and delta 2 can be found as 3 by 2, 1.5 micrometers. Okay, so this is the final answer. If you look at this options here, square root of 9 into 4 micron, square root of 9 by 4, square root of 4 by 9, 1 by square root of 9 into 4. So out of this, the right option will be root of 9 by 4. Okay, coming to the next question. The electric field component of a uniform plane electromagnetic wave. The electric field component of a uniform plane electromagnetic wave propagating in the y direction in a lossless medium will satisfy the equation. So, if you look at the expressions, dou square Ey by dou y square is equal to mu epsilon dou square Ey by dou t square. Coming to second option, dou square Ey by dou x square mu epsilon dou square Ey by dou t square. Third option, dou square Ex by dou y square is equal to mu epsilon dou square Ex by dou t square. And the last option, square root of Ex square plus Ez square divided by root of Hx square plus Hz square is equal to root of mu by epsilon. So, if a uniform plane wave is propagating in y direction, electric field and magnetic field should be functions of y and t. So, in case of an EM wave that propagating in y direction, so we can write the electric field and magnetic field as functions of y and time t, satisfying the second order partial differential equation in y and t. So I can write it as components of electric field or magnetic field in the direction of propagation of, so it could be written as dou square Ex, or I'll just write it like, or Hx by dou y square is equal to mu epsilon dou square Ex, or I can also write it like, or it could be Ex or Hx by dou t square. Similarly, E and H are related as E by H is eta. So, to represent that, Ez by Hx is eta. Similarly, Ex by Hz is minus eta. So, E by H is square root of Ex square plus Ez square divided by Hx square plus Hz square. So, therefore, we can write it as eta, where eta is the intrinsic impedance of the medium. Eta naught is root of mu by epsilon. So the answer option here for the fourth question is option C and option D. So if you look at the option C, dou square Ex by dou y square is equal to mu epsilon into dou square Ex by dou t square, and the ratio root of mu by epsilon is nothing but E by H, which is nothing but the magnitudes. So E is square root of Ex square plus Ez square, and magnitude of H is nothing but square root of Hx square plus Hz square. Moving on to another question here. A material is described by the following electrical parameters at a frequency of 10 gigahertz. That is, sigma value is given, mu is equal to mu naught, epsilon by epsilon naught. So to note, epsilon by epsilon naught is nothing but epsilon r, with the value is 10. The material at this frequency is considered to be, so we are also given the epsilon 0 value here. So the material, we need to identify whether it is a good conductor, dielectric, whether it's a good dielectric, whether it is neither a good conductor nor a good dielectric, and finally whether it is a good magnetic material. So let us try to solve this. The material parameters, sigma is 10 power 6 mole per meter, mu is mu naught, and epsilon by epsilon naught, which is epsilon r, is 10. Okay. So sigma by omega epsilon. So to identify whether it is a good conductor or a good dielectric, we need to take the ratio sigma by omega epsilon. So sigma value we can substitute as 10 power 6, and by omega, so in the question the omega value is the frequency is given as 10 gigahertz. So let us write it down, 10 gigahertz, and so 2 pi f, which is 10 into 10 power 9 into epsilon. So let me clear that out. Epsilon is nothing but epsilon 0 into epsilon r. So epsilon 0 is 1 by 36 pi into 10 power 9 into epsilon r is 10. So taking this, substituting this epsilon r value and 1 by 36 pi, so that becomes 36 pi into 10 power 9. So solving this, the final answer would be 18 into 10 power 4. So which is much greater than 1, which indicates that at this particular, so sigma by omega epsilon ratio is much greater than 1, which indicates that it is a good conductor. So the answer options, we had good conductor with good dielectric, neither a good conductor nor a dielectric, So out of this, the option is good conductor. Okay. So now moving on to the next question. Okay, now let's solve this 7th question here over here. A uniform plane wave in air is normally incident on an infinitely thick slab. If the refractive index of the glass slab is 1.5, then the percentage of incident power that is reflected from the air glass interface is. So to answer this, so here you have a medium 1, which is air, and then you have a medium 2, which is glass. So the refractive index of air is 1 and refractive index of glass is 1.5. Mu 1 is mu naught and mu 2 is also mu naught. Epsilon 1 I can write for air as epsilon 0 and epsilon 2 is epsilon 0 into epsilon r. So to remind you about what is asked in the question, so the question is the uniform plane wave in air is normally incident on this glass. So refractive index is known to you. How much of the incident power is reflected from the air glass interface? So if you take the ratio n1 by n2, n1 is root of mu1 epsilon 1 by root of mu2 epsilon 2. So basically mu1 and mu2 are same. So we can write it as root of epsilon 1 by epsilon 2. So this would be n1 by n2, we have 1 by 1.5. So the ratio, the reflection coefficient. So once if you want to know the how much power is reflected back, you should calculate the reflection coefficient. So reflection coefficient gamma is ER by EI, which can be written as root of epsilon 1 by epsilon 2 minus 1 divided by root of epsilon 1 by epsilon 2 plus 1 and 1 minus 1 by n2. So to n1 by n2 minus 1 by n1 by n2 plus 1. So that way I can write this. So this is 1 by 1.5, which is nothing but 2 by 3. So 2 by 3 minus 1 by 2 by 3 plus 1. So which finally you get this as minus 1 by 5. So this is the ratio of reflected electric field to the incident electric field. To find out the ratio of power or how much power is reflected back, so PR by PI would be ER by EI square. Okay, ER by EI, the ratio ER by EI, take the ratio and square it. So 1 by 5 square, which is nothing but 1 by 25, which is accounting for a 4% reflectivity. Okay, so 4% of incident power will be reflected. Okay, so now let's move on to another question here. Some unknown material has a conductivity of 10 power 6 mole per meter. So we are looking at question number 8. 10 power 6 mole per meter and permeability of 4 pi into 10 power minus 7 Henry per meter. The skin depth for the material at 1 gigahertz is. So skin depth is delta is equal to 1 by root of pi f mu sigma. So it is 1 by root of pi into f value, because the frequency is given as 1 gigahertz, so 10 power 9 hertz, into mu value is the mu naught, so 4 pi into 10 power minus 7, and sigma value is given as 10 power 6. So if you solve this, you will get the final answer for the skin depth. So this is a direct question if you know the relationship delta equal to 1 by root of pi f mu sigma. So the final answer will be 15.9 micrometers. So here in the answer options, it is option A. Eighth question, option A. Okay, now moving on to ninth question. A uniform plane wave in air impinges at 45-degree angle on a lossless dielectric material with a dielectric constant epsilon r. The transmitted wave propagates in a 30-degree direction with respect to the normal. The value of epsilon r is. So the angle of incidence between the air and the lossless dielectric is given as theta I is 45 degree. Angle of refraction sorry. So uniform plane wave is incident at 45 degree, and if you see the angle of refraction or the transmitted wave will propagate 30 degree with respect to the normal. Okay, so theta t is also given to you. So applying Snell's law, we can write, so let us write theta t is 30 degree. We know that n1 sine theta I is equal to n2 sine theta t. So n1 is so we can write n1 by n2 is sine 30 by sine 45. Sine 30 is 1 by 2 and sine 45 is 1 by root 2. So this comes to be 1 by root 2. Okay, n1 by n2 is root of epsilon 1 by epsilon 2. Okay, so we know that, okay, so this could be written like 1 by root 2. We know that the first medium is air, so epsilon 1 is nothing but epsilon 0 and epsilon 2 is epsilon 0 into epsilon r. Okay, so in that case I can write epsilon 0 by epsilon 0 into epsilon r, okay, is 1 by 2. So we just square both sides. So epsilon 0 is getting cancelled and epsilon r is nothing but 2. So because it is a air dielectric interface, so the first medium air has epsilon 0, and second medium has a relative permittivity, and we found that relative permittivity based on the for a known value of angle of incidence and the angle of transmission. Moving on to another question. See the 10th question here. That's an easy question. But the concept should be very basic understanding of the concept. A uniform plane EM wave incident normally on a plane surface of dielectric material is reflected with a VSWR of 3. What is the percentage of incident power that is reflected? Okay. To answer this question, okay, so we know that the uniform plane wave incident normally on a plane surface and is reflected with a VSWR of 3. Okay, so what is the expression for VSWR? We know that VSWR rho is equal to VSWR is expressed as rho is equal to 1 plus mod gamma by 1 minus mod gamma. Okay, or I can write gamma is equal to rho minus 1 by rho plus 1. Okay, so 3 minus 1 by 3 plus 1, which is 1 by 2 by 4, which is nothing but 1 by 2. Okay, so now you know that the reflection coefficient is 1 by 2. So the ratio, so that is nothing but the ratio. So reflection coefficient is basically ER by EI, the ratio of electric field vectors. Okay, incident reflected to incident. So to find how much power is reflected, PR by PI, take the square of this. So that will be 1 by 2 square, which is 1 by 4. Okay, which is nothing but 25%. Okay, so 25% of incident wave will be reflected back. Okay. So this will be the question is about the percentage of incident power that is reflected, which is nothing but 25%. So option B. Okay. Now let's look at a different question. Question 12. We have never discussed some questions on loss tangent. So that will be a good question to discuss. Distilled water at 25 degrees centigrade is characterized by sigma value is there. Sigma is 1.7 into 10 power minus 4 mole per meter. Epsilon is 78 epsilon 0 and the frequency is 3 gigahertz. Okay, is loss tangent is being asked. Loss tangent is also called like tan delta. Okay, so coming to solving this question, so the loss tangent, very important understanding of loss tangent we have discussed many times. Sigma by loss tangent, loss tangent is nothing but sigma by omega epsilon. So sigma is 1.7 into 10 power minus 4 divided by omega is 2 pi f 3 gigahertz 3 into 10 power 9 into epsilon is epsilon 78 epsilon 0. Okay, so 78 into epsilon 0 value is 8.85 into 10 power minus 12. Okay, this is the denominator itself. So tan delta, if we evaluate, we get it as 1.3 into 10 power minus 5. So that will be the Low's tangent. So in the question, it's option A, 1.3 into 10 power minus 5. Hello, am I audible? Can you respond? Is there any doubts? Maybe you can type in the chat as well. If you have an issue with the mic, you please uh, respond in the chat. Okay, thank you, Anandan, for responding. Is there any doubts which you have? Because we are nearing to the final examination. Do you have any, do you need any particular clarifications in any of the topics? Okay, thank you. So I will discuss one more question and I'll wind up the session. Okay, so this is an interesting question. Question number 14. Question number 14. A uniform plane wave traveling in air is incident on the plane boundary between air and another dielectric medium with epsilon r equal to 4. The reflection coefficient for the normal incidence is. So, uh, reflection coefficient can be written as ER by EI in terms of so okay, in terms of refractive index, we can write it as root of epsilon 1 by epsilon 2 minus 1 divided by root of epsilon 1 by epsilon 2 plus 1. Okay, so the first medium is air and the second is a medium. So we can write it like this: 1 by root of 1 by epsilon r minus 1 by root of 1 by epsilon r plus 1. So the relative permittivity of the second medium is written as 4. So this comes out to be 1 by 2 minus 1 divided by 1 by 2 plus 1. So the final answer will be minus 1 by 3, for which we can write it as 0.33 is the magnitude and the phase is 180 degrees. So the minus represents phase of the reflection coefficient, which is 180 degree, and the magnitude of the reflection coefficient is 0.33. So here among the options, it is 0.33 angle 180 degree. That is option D. Okay, I think we have time to discuss one more question. Okay, let's see this one. 15th question. If the electric field intensity associated with a uniform plane EM wave traveling in a perfect dielectric medium is given by E of Zt is equal to 10 cos of 2 pi into 10 power 70 minus 0.1 pi Z volt per meter, the velocity of traveling wave is. So this equation, if you look at the equation, so let us just note it down and write it like an expression. Electric field is 10 cos of 2 pi into 10 power 70 minus 0.1 pi Z. So the question is the velocity of traveling wave. So this is of the form omega t minus beta Z. Okay. So to find the velocity, it is omega by the ratio omega by beta. So it will be 2 pi into 10 power 7 divided by beta is 0.1 pi. So pi gets cancelled and it is 2 into 10 power 8 meter per second. So that will be the velocity of the traveling wave. So this is a simple question. Once if you see the expression, find out what is omega, what is beta. Take the ratio of omega by beta, that gives us the velocity of the traveling wave. So the final answer is 2 into 10 power 8 meter per second, which is option B. So if there are any doubts, please ask, or we'll wind up the session. Okay, thank you.